everyone. In this video, I shall discuss the solution of question number 46 of GATE Physics 2021. This is a multiple select question. The time derivative of a differentiable function g is added to a Lagrangian L such that L prime is equal to L plus ddt of g, where g is function of generalized coordinate and time. Here qy dot and t are the generalized coordinates, generalized velocities and time respectively. Let p be the generalized momentum and h the Hamiltonian associated with the Lagrangian. If pi prime and h prime are those associated with L prime, then we need to choose the correct options. Let's solve this question. In this question, g is a function of generalized coordinates and time. As L is the Lagrangian, we have del L del Qy equal to ddt of del L del Qy dot. This is the Euler-Lagrange equation. Now we'll find out del L prime del Qy minus ddt of del L prime del Qy dot. This will be equal to del L del Qy minus ddt of del L del Qy dot plus del Qy of dg dt minus ddt of del Qy dot of dg dt, where g is a function of generalized coordinates and time. So dg dt is equal to sum over I del g del qy into qy dot plus del g del t. So del qy dot of dg dt is equal to del g del qy. So ddt of del qy dot of dg dt equal to ddt of del g del qy. This can also be written as del qy of dg dt. So del qy of dg dt is equal to ddt of del qy dot of dg dt. So in this expression, third term and the fourth term cancel out, as L is the Lagrangian. The first term and the second term also cancel out. This means del L prime del Qy is equal to ddt of del L prime del Qy dot. So L prime also satisfies Euler-Lagrange equation. So both L and L prime satisfy Euler-Lagrange equation. So option A is correct. Now the generalized momentum pi prime is equal to del L prime del Qy dot. This is equal to del L del Qy dot plus del Qy dot of dg dt, as L prime is equal to L plus dg dt. Del L del Qy dot is equal to pi and del Qy dot of dg dt is equal to del g del Qy. So pi prime is equal to pi plus del g del Qy. In option B, it has been given that pi prime is equal to pi plus del g del Qy. So option B is correct. Now if pi is conserved, pi dot is 0, then pi prime dot is equal to pi dot plus ddt of del g del Qy. Here pi dot is 0. If pi is conserved, pi prime dot is equal to ddt of del g del Qy. So pi prime dot can also be written as del Qy of dg dt, as g is a function of generalized coordinates and time. Dg dt will also be a function of generalized coordinates and time. So del Qi of dg dt is not necessarily 0. So Pi prime dot is not necessarily 0. This means Pi prime is not necessarily concept. This means option C is not correct. Now the Hamiltonian H is equal to sum over I Pi into Qi dot minus L, and H prime is equal to sum over I Pi prime into Qi dot minus L prime. Here Pi prime is equal to Pi plus del G del Qi, and L prime is equal to L plus dg dt. So H prime is equal to H plus sum over I del G del Qi into Qi dot minus dg dt. dg dt is equal to sum over I del G del Qi into Qi dot plus del G del T. We replace dg dt with sum over I del G del Qi into Qi dot plus del G del T. After some simplification, we find that H prime is equal to H minus del G del T. In option D, it has been given that H prime is equal to H plus dg dt. So option D is not correct. Thus, we have found that option A and option B are correct. So in this question, option A and option B are correct.